And we're back. We're looking at 6.5. We're looking at the cosine law. This is the lesson that makes me hungry every time we talk about it. Why, you ask? Well, thank you for asking. So again, we're looking at triangles that don't have right angles. And we are going to be developing and applying the cos law. Yum, yum. All right, let's look at this first one. Got a triangle there. Hey, we do have a right angle triangle in this first one right there. So let's get through. We want two expressions for b. Hey, we can get a few more than two, but let's just get two of them to start with. All right. Well, first thing, right angle triangles. The things that work for right angle triangles are either our Pythagorean theorem, or we've also got, that works in the right angle triangles, we've got our trig ratios. So we're going to look at both of those with them. First thing, Pythagorean theorem. We can solve for b by saying b squared equals a squared plus c squared. Notice how they drew the triangle. The labeling of the sides is arbitrary. C doesn't have to be the hypotenuse, doesn't have to be the longest side. In this triangle here, we've got our c value way over here. Now this here that I wrote, that's b squared, but I need to have the expression for b. So, whoop, let me change that back. We got b is equal to the square root of a squared plus c squared. There's one expression. Second thing, we're looking at trig ratios now. Well, we could be using any of the ratios that have the hypotenuse as one of the sides. So either sine or cosine. So we're going to have sine of angle A is equal to, if we're talking about this angle, we can use the opposite over hypotenuse. So we could say A over B. So then B is equal to A over sine A. We could have done the same thing from angle C. So we could have said sine of C is equal to C over B. So then B is equal to C over sine C. We could have also talked about cosine. So we could say cosine of angle A is equal to adjacent. So C over B. Do the same thing. B is equal to C over, cos A. Or we could have done cos of C equals A over B. So then B is equal to A over cos C. Lots of other, and there's other ones too. We could have went along, we could have split this triangle. There's so many different ways of being able to talk about B. What we're going to be doing today is we're going to be looking at combining the Pythagorean theorem one and our cosine one, kind of slamming them together when we don't have our right angle triangle. All right, so when two sides and the contained angle of a triangle are known, what are they talking about? They're talking about knowing this side, let's call it A. Knowing this side, let's call it B. Knowing this angle, let's call it angle C. If we know that right there, side, angle, side, then you know what? The sine law isn't going to help us. So we need to have something, a different way to go about it. Your textbook goes through and it develops the cosine law. In class, I'm going to develop it in a slightly different way, which I think is a little bit easier to understand. Okay, so for right now, we're going to, you can see it there in your book, we're going to jump straight down to saying this, oops, let's erase part of that there, and this one. 3 different forms. It doesn't matter which side we're talking about, there's a pattern that's involved. Notice the pattern. If we're looking for b squared, then we take it and we're going to add the other 2 sides, and then we're going to subtract 2 times the other 2 sides, cos of the angle that is related. Same thing, add the 2, subtract, multiply 2 times the other 2, and cosine of the angle that is related. So the key here, the side which we're talking about, they're arbitrary. This is the formula that we're going to be using. The c squared equals a squared plus b squared minus 2ab cos of c. And again, in class, I'm going to go through and I'm going to show where does it come from. We're going to derive it. We're going to develop that whole formula. Pythagorean theorem is actually a special case of the cosine law. If we look at it here, all we're doing is we're plugging in 90 for the angle, and the cosine of 90 degrees is 0. So that wipes out this whole part, and we just get the Pythagorean theorem. I just talked about it. Make a note for yourself. How are you going to remember what goes where in the formula? All right, we're jumping right into number 1 here. We're looking at finding Q2R right there. So we're looking for that length. We're looking for that length. Oh, but wait. Our formula that we had was c squared equals a squared plus b squared minus 2bc cos of a. I don't have any a's, b's, and c's on there. So that's why in that last question I asked you, bring it together. How are you going to remember what goes where? So, well, opposite of angle P is little p. Opposite of angle R is little r. Opposite of angle Q, little q. Well, let's go through it. I'm looking for P. So P squared equals, we've got the A's and the B's. So the other 2, we're going to add the other 2 squared. So Q squared plus R squared minus 2 times the other 2, Q and R. And then the cosine of the related angle. If we're looking for P, it's the cosine of P. Some of you might need to say, okay, wait a minute, I'm just going to change it to A's, B's, and C's and work from there. That would be acceptable as well. Let's plug in what we know. So P squared equals Q squared, 10 squared, plus 17 squared, minus 2 times 10 times 17, cos of 31 degrees. All right, so you got a couple options here now. You could do it step by step all the way through, or you could punch it into your calculator in one shot and then square root that answer. Either way will work. My recommendation for you is to punch it into the calculator in one shot. A lot less mistakes get made. Otherwise, people start subtracting before they're multiplying. They get the order of operations messed up. So let's plug in this whole shot right into calculators once. Check it out. Make sure that you can. P squared is equal to, when you plug it in, check it out for yourself, 97.56 dot dot dot. I have to leave that in my calculator and square root the answer. Okay, so we're going to now find square root both sides. So P is equal to the square root of the answer. You can't type in the 97.56. And then when you hit that, we get approximately 9.877 dot dot dot. And we want to the nearest tenth. There we go. P equals approximately 9.9 centimeters. Done deal on that one. Let's check out the next one. All right, labeling our sides again. Across from the P, across from the Q, across from the R. Oh, look at that. The R is 17. The Q is 10. Hey, those are the exact same numbers as we had in the last one. The only difference here is that our angle is 100 degrees larger. So start with your formula. Always start with your formula. I need you to write down the formula before you fill it in. Formula substitution, work to the answer. So p squared equals, we got q squared plus r squared minus 2qr, cos of p. Fill it all in. And that equals, again, 10 squared plus 17 squared minus 2 times 10 times 17. Cos of, this time it's 131. It's the only difference there. Now, a lot of you will say, hey, well, wait a minute. Why don't I just do it all in one shot instead of doing it once and then hitting the square root of the answer? Great, do it. Take your square root right off the bat. If you can handle that, do it. Then we just punch it in one shot, and we get 24.7398 ... Please check to make sure you can yourself plug it into your calculator. You want to know now if you have a problem with that, which is approximately equal to, again, nearest tenth, 24.7 centimeters. Bang. Done. Now in that example we just did, how did we know that we couldn't use the sine law? How did we know that we had to use cosine law? Write that down. Oh boy, getting a little bit trickier. You gotta draw the triangle yourself. Oh. There we go. KMN. Arbitrary, doesn't matter, put whatever. K, M, N, doesn't matter which order you put them in. Now, K to M, that's 16 centimeters. This now matters that you put the numbers in the right spot. K to N is 11 centimeters, and M to N is 6 centimeters. Ooh, I've got no angles, but I am looking for angle M. So we've got side, side, side. We can't use sine law either. We've got to use cosine law here, but we're looking for an angle in this one. So let's start by writing out what we've got. We're looking for angle M, so I'm going to need to be dealing with the M. So M squared is equal to, add the other two sides, N squared plus K squared minus 2 times N times K cos of M. So now our first option is to plug in our information as it is right now. Let's do that. So we've got 11 squared equals 6 squared. Oops, sorry, that one is actually 16 squared. There we go, plus 6 squared minus 2 times 16 times 6 cos of M. And we're trying to isolate now and solve for, get cos of M isolated, and then we'll do the inverse cos to get M by itself. Let's start taking things over. This is where people make their mistakes. This is multiplied to the cos of M. That's a package. These other two, I can subtract over to the other side. I can add them together if I wanted to right now. But I cannot combine all of that together. We got different order of operations going on there. Let's get rid of our squareds here. So 11 squared, 121. 16 squared, 256. 6 squared, 36, minus 2 times 16 times 6. Oh, that's 192. Everyone should know that. Cosine of M. So this one and that one I can subtract over to the other side. Or I could add them together if I wanted, but I'm just going to subtract them over. So I'm going to go subtract 256, subtract 36, subtract 256, subtract 36. And that's going to give me my next line. 121 minus 256 minus 36 gives us negative 171 equals negative 192 cos of M. This is where the biggest mistakes get made, is people subtracting that off. We've got to divide both sides now by the negative 192. That's the key here. So we now have the cos of M is equal to, they're both negative, so I'm just going to make them positive, 171 over 192. Do the inverse cosine to get M by itself. Punch that into your calculator. And we've got 27.0481 dot dot dot, or approximately m is equal to 27 degrees to the nearest tenth. Or sorry, to the nearest degree. Now instead of every time plugging in the values and taking them over to the other side, it sure would be nice if we had a formula that was done for us. So we're going to work it through off of the basic. Let's look at c squared equals a squared plus b squared minus 2ab cos of c. Let's isolate cos of c in the general form. So we're going to subtract a squared, subtract b squared to the other side. Or alternatively, which would be nice to get rid of this negative that's kicking it here, let's take that over to the other side first. So I'm going to instead, just so I don't have any negatives there that I have to deal with in this first step, I'm going to add 2ab cos of c. That's a package. It goes together. Let's add it to the other side. So now I'm sitting with c squared plus 2ab cos of c equals a squared plus b squared. These ones canceled off there. And let's get the c squared over to the other side now. So we're going to subtract c squared, gives us 2ab cos of c equals a squared plus b squared minus c squared. Last step, we got to get cos of c by itself. I'm going to divide by the 2ab. So here's now your formula. Cos of c equals a squared plus b squared minus c squared over 2ab. Again, there's a pattern. Add the two other sides. Subtract the related one. Divide by 2, and the other two sides multiply. All right, let's look at b then. Let's draw it up. We've got STU, triangle, STU, and label up our sides. ST is 16, SU 20, and 6. The only thing we've changed is that we've changed it into 20 from 11. Let's check it out. We're looking for angle T now. Well, I'm going to use my newfound formula. Cos of T this time is equal to, add the other two sides, not the T side. So this is T, this is S, this is U. Label always your triangles. So we've got U squared plus S squared minus the related side, T squared, over 2 times U times S. All right, fill in what we know. Cosine of T, there we go, equals 16 squared plus 6 squared minus 20 squared over 2 times 16 times 6. You can now punch it straight in. Please be careful with this. Bracket numerators, bracket denominators. You can punch it in one shot into your calculator and then inverse cosine the answer there. Or if you prefer, you can punch it in the numerator and the denominator. I'm going to do that. I'm going to get cos of t equals, the numerator punched in gives me negative 108. Denominator punched in gives me 192. And then I'm going to do my inverse cosine of negative 108 over 192. A little bit safer this way. Punch it in, and we get 124.2288 dot dot dot. T is equal to approximately 124 degrees. Decide which way you like better. Do you like starting with the new formula, which you're going to have to remember, or plug it into the other formula and then just algebraically solve each time? Okay, word problem time. We got a retaining wall. It is leaning at an angle of 70 degrees to the horizontal. So let's start looking at this. This is where the wall is supposed to be, but all of a sudden, whoop, it falls over. And we've got 70 degrees to the horizontal, so it's inside there. So there's our retaining wall sitting there. A rigid support is to be placed 5 meters from the base of the wall. So 5 meters away, we're going to place a rigid support. And that rigid support is going to be attached to the wall 2.5 meters up. So there we've got our triangle. Let's label it and let's use A, B, and C. If we get to choose, why not use A, B, and C? A, B, C. Doesn't matter where you put them. I'm going to do it this way. And we are wanting to know this value there, the B. So start with our formula. B squared equals, add the other two. This is A, that's C. So we've got A squared plus C squared minus 2AC cos of B. B squared is equal to 5.0 squared plus 2.5 squared minus 2 times 5 times 2.5 cos of 70. And again, plug it into the calculator, square root it right off the bat, and we get to 4.7643 ... All right, we found that. We found the B, but it says also, and now find the measure of the angle between the support and the wall. The support and the wall, that's up here. This is the angle we now got to find. We could use cosine law again. Cosine law, that's got lots of stuff happening. We know almost everything in this triangle. We know enough information now to be able to use sine law. Hey, sine law looks a lot easier. Let's do it. So we are looking for angle A, so sine of A is going to be divided by the A, and that's going to equal sine of B divided by the B. Hey, I know 3 out of the 4, so let's fill it in. Sine of A over 5.0 equals the sine of 70 over the B value, which is 4.7643 ... Hey, whenever we're going to have to use a number, we want to store it into the calculator. So I want that number stored into my calculator. I don't want to type in a number that's been rounded. So sine of A is equal to 5.0 sine of 70 divided by 4.76 ... A is equal to the inverse sine of that. 5 times the sine of 70 over my 4.76 ... Put in the dots to make sure I know I'm carrying the decimal. When we punch that into our calculator, we get angle A being approximately, well, it's 80.4567 ... or approximately equal to 80 degrees. Length of B, oh, we needed the nearest tenth, 4.8 meters and 80 degrees. Okay, in comes now headings or bearings. They don't use standard position. So this, we've got to make a note of this. Not the rules of standard position. Be careful with that. They come up with their own rules. Their rules are you start at the north and you go clockwise to be the positive direction. So if I'm talking about 270, I start here and I go that way, instead of standard position where it started at the positive x. We're using north, south, east, west. If I'm talking about 70 degrees, again starting at the north, we go 70 degrees. For our question, we're going to actually look first of all at the question that's in your book. we're going to let Buddy explain it for you. Here we go.
From the top of a 30-meter observation tower, a fire ranger observes smoke on a bearing of 90 degrees with an angle of depression of 5 degrees. The ranger spots more smoke on a bearing of 200 degrees with an angle of depression of 2 degrees. To the nearest meter, how far apart are the sources of smoke? I'll start by labeling the diagram. I'll use R to represent the position of the ranger, P to represent the base of the tower, and S and T to represent the sources of smoke. The height of the tower is 30 meters. I'm going to assume the tower is perpendicular and the ground is horizontal, so angle RPT and angle RPS are both 90 degrees. I'm trying to determine the length of ST, which represents the distance between the sources of smoke. If I look at triangle PST, I can use the cosine law to determine ST. First, I need to determine S or PT. I'll use right triangle RPT to do this. Angle R is 90 degrees, subtract 5 degrees, or 85 degrees. I'll use the tan ratio to determine PT. Angle R is 85 degrees. The side opposite angle R is PT. The side adjacent to angle R has a length of 30 meters. I'll multiply both sides by 30 to isolate PT. So, PT equals 30 times tan 85 degrees. I'll label PT on the original diagram. Next, I need to determine T, or PS. I'll use right triangle RPS. Angle R is 90 degrees, subtract 2 degrees, or 88 degrees. I'll use the tan ratio to determine PS. Angle R is 88 degrees. The side opposite angle R is PS. The side adjacent to angle R has a length of 30 meters. I'll multiply both sides by 30 to isolate PS. So, PS equals 30 times tan 88 degrees. I'll label PS on the original diagram. Now, I need to figure out the measure of angle P in triangle PST. Angle P is the difference between the two bearings, which is 200 degrees minus 90 degrees, or 110 degrees. I'll label angle P on the original diagram. Now, I can substitute the calculated measures into the cosine law to determine ST. S equals 30 times tan 85 degrees. T equals 30 times tan 88 degrees. Angle P equals 110 degrees.
Okay, another alternative is to use the triangles, plug it into your calculator, and store the values that you get for the two bases on those triangles. It's a little bit easier than trying to punch it all in one big shot. It gets a little bit crazy. So my recommendation, plug it in, store that value, and then use the stored value, like store this one into alpha A. Then you just put alpha A into here. Store this into alpha B, put alpha B in there.
So, P equals approximately 1028.1630. So, the sources of smoke are about 1028 meters apart.
Fun stuff. My recommendation for you, you can try out this number for yourself right now. See how far you can get. See how much you understood. I will go through this one in class a little bit slower. Take it step by step all the way through this tougher type of a question with the navigation. Okay, just bring it in. When would you use cosine law? if you're looking for side length. When would you use cosine law if you're looking for the angle? When would it happen? Write it down, and we'll see you in class.